thank you for having me here. So what I thought I'll do today is, instead of talking about health and wellness, which you've heard now from two experts, I'll talk about how the world of mobile is shaping the world of marketing. Okay? So just to give you some sort of a heads up into where I'm coming from, if you take a look at this screen, what you would see is that if you compare the usage of our usage across 5 different channels, such as newspapers and internet and TV and smartphones, there is a pretty big inefficiency here in the sense that we are spending, the blue bar tells us how much time we are spending, and the yellow bar tells us how much money is being spent in terms of advertising. So the blue bar is giving you that 18% of our time, 4% of our time is spent on newspapers, but 18% of our money is being spent on newspapers. Whereas in the world of mobile, it's the opposite. It's 24% of our time is being spent on smartphones and tablets, but only 8% of advertising dollars are being spent on the channel. So I've been working in this space for about the last 8 or 9 years, ever since smartphones and tablets came into space. And my curiosity in this space was really triggered by this inefficiency. And even though this is a chart from 2014, and if you go back in the previous years as well, there has been this gap. And my colleagues and I have been trying to figure out how do you actually monetize this gap, right? So, and this is where like data science and behavior analytics become really useful, because as you understand more and more about consumer behavior, you can actually use that and mine that efficiently to figure out ways to monetize this gap. Okay? So my work has taken me to different parts of the world. Aside from the US, of course, I've also worked in China and in South Korea. And in India and Europe, I've worked a lot in Germany and in South America. So one of the things that we have learned over time is, even though the laws and the regulations regarding data from mobile devices may vary from country to country, people are fundamentally the same everywhere. Okay? And this may or may not come as a surprise to you, but data doesn't lie. So if you look at the actual behavior analytics of people from Brazil to Germany to India to China to Korea to the US, when it comes to smartphones and mobile marketing and mobile advertising, I see no difference whatsoever in people's propensity. Okay? And this is something that going in, I personally did not anticipate. I thought there'd be some differences with respect to culture or geography, but we don't. So, and that being said, where the real interesting differences lie are in terms of the adoption of different channels. So, for example, mobile can be, if you think of mobile, it's one device, but it has 3 or 4 different sub-channels, right? So there's mobile app, there's mobile video, there's mobile text, there's mobile display. And so what we have done is we've basically taken each of these ecosystems one after another and try to figure out when does advertising work in which channel, and what makes some things tick, what makes some things don't tick. And when it comes to advertising, we've looked at pretty much all predominant forms of advertising. So obviously mobile by definition is a portable device, which means that you get access to location. So location-based advertising is obviously popular and it's also easy to execute. But increasingly, we've also looked at other forms of context-based advertising. So location alone is not sufficient. What we've realized is if you combine location with time, it makes a lot more of a difference. If you combine that with weather, okay, our behavior on a smartphone is actually even influenced by what happens outside with respect to weather. When you look at crowdedness, are we actually situated in isolated context or are we in a crowded context? All of these things tend to influence the actual propensity for people to redeem offers. Okay. So I'll basically walk you through a few different studies in different parts of the world that we've done. And like I said, the fundamental theme around all of this is going to be consumer behavior analytics, right? So we get lots and lots of data, and as you can imagine, data from smartphones, we're talking about gigabytes, terabytes, petabytes of data. And as you walk through this digital trail, right, and you observe people and consumers at every milliseconds, depending on the context, you can really capitalize on that rich trail of data. So I'll start by this notion of geofencing, and some of you may be aware of what this is. But if not, what this really means is that this is basically an example of 3 consumers, and using a variety of location-based technologies, all the stores in the vicinity of these consumers are able to target them with certain set of offers. Okay? And these offers may come in a wide variety of forms. Depending on the country and the regulation, they may come in the form of an SMS, or it may be coming in the form of an ad in an app, or it may be a mobile video. It could be a variety of things, but this can be done, and this has been done. So we looked at, one of the earliest projects we had done was looking at the effectiveness of geofencing, and basically to compare that with, traditional marketing. So, sending direct brochures, direct marketing, or even emails. And if you look at some of the differences, so some of the comparisons with geotargeting and email and direct marketing suggest that geotargeting, if it's done effectively, it can be rather quite efficient. Okay? So if I look at, I'm giving you two examples here, one from the food category, Dunkin' Donuts, which is like Starbucks, in the US. And then we also looked at some department stores, and again doing geofencing and geotargeting. And if you compare the click-through rates and the conversion rates with direct mail and email, what you'd see that for email, the CTR was so much, and the conversion rate was about 1.73% for email targeting, and for direct mail was about 1.38. But for each of these, we got almost twice that number of conversion rates. Okay? And they were relatively, effectively similar samples, no systematic differences in demographics. These are massive randomized experiments, and obviously when you're looking at a randomized experiment, you want to think about selecting a sample very, very carefully. So all else equal, what it suggested to us was the potential for geotargeting exists. And now the question is, how can we improve it? Okay, so this was the earliest set of studies that told us that, look, there is some potential, the numbers are promising. Okay? Now, what can we do behind the scenes to make it more effective? Okay? That's where we started clubbing in other contextual factors, such as time, weather, crowdedness, et cetera, et cetera. Okay? So here's one set of studies where this was done in Europe, in Germany, and this was a massive project. If you look at the scale, we had to basically collaborate with more than 3,000 different retailers, individual retailers and stores and brands. And this was a project with E+, which is one of the 3 telecom providers in Germany. And this was done across 300 towns and cities. And the idea here was that as opposed to geotargeting, which would be in the form of an SMS, how about instead of pushing offers out, we try to elicit consumers to pull offers from us. Okay? And how would this work? This would work because we would have an app. This app would be an aggregator of all retailers' offers who would participate with us. But the difference was, as opposed to a generic set of offers, the offers would only come based on where you're located. Okay? So if I'm located right now here in the high-tech campus, so any retailers in the vicinity who are participating with us in this consortium would be able to target me with an offer. Okay. Now, there are 2 interesting questions here. One is, of course, what is the right level of discount you would want to give to each consumer? Okay. So the simple example is, if you got somebody, and you can see here the distances measured as well. Somebody is 357 meters away, another person is 500 meters away. Now, presumably, the person who is further away, you'd want to give him or her a higher discount in order to elicit them to walk to your store and redeem the offer, right? And the person who is closer, you probably want to give them a lower discount, right? So, at the very basic level, the simple hypothesis is distance and discount have a trade-off, and how do you customize the discount in real time? And mind you, this is not going to be, in batch mode in real time. Okay? So this is where, the large-scale data and the massive scale of the project was useful, because, as opposed to looking at a handful of people, in a given city and town, we started to basically expand this across the whole country, right? And what we were able to do was go back and figure out, like, for every 1 meter or every 1 kilometer distance between the user and the store, what would be the ideal level of discount. Then we institutionalized those campaigns. We ran those discounts. Then we went back and corroborated that with what our model had predicted. And lo and behold, surprisingly, and well, maybe not so surprisingly, we actually saw a 3 times higher redemption if we did it right. So again, this was the first set of studies done anywhere in the world that actually looked at this distance discount trade-off. The fact that you could increase redemption rates from the previous 2 to 3% going up to almost double digits also seemed very encouraging and promising. And all we did was we basically said, look, don't give everybody the same discount. You want to customize or personalize it based on distance. Okay. So that being said, then things took another interesting turn. The next project took us way back in the Far East in South Korea. So this is a screenshot from Seoul. If you've been there, recognize the Han River that divides the city into north and the south. So here, the two big telecom providers, SK Telecom and Korea Telecom, gave us a massive data set of several 100,000 consumers in the city of Seoul. And based on that data, what we know is, let's say you've got John Doe. On a certain day, John Doe starts from his home. He goes to his office, and from his office, he goes to another third slot, and then he comes back home. Okay. On another day, John Doe again starts from his home, and he goes to his office. He goes to whatever his client call is. But instead of coming back home, he actually makes a detour. He goes to another spot, and then he goes to another spot, and then he comes back home, right? So basically, of the more than almost 500,000 consumers or users of the telecom company subscribers who we analyzed, we saw that almost the vast majority of people had these two distinct patterns of traveling. On the majority of days, they would have the regular commuting, which is home to work and back. And then on certain days, they would actually make some deviations. And it could be, it could be a shopping trip, it could be a client call, it could be a trip to a movie ticket, theater, whatever it is. But we could see these two different clusters, right? And so, based on mining that behavior, what we realized is that if nothing else, what we could do is we could examine if people are more likely to redeem mobile coupons or mobile commerce offers on the days when they're commuting to office and back versus on the days when they're deviating. Okay. So then we ran another, multi-month, multi-product campaign that involved, apparel, retail, cosmetics, fast food, and pretty much every other product we could think of. And then we said, okay, we're going to target people with offers on the days when they're commuting and on the days when they are deviating to examine which days are better for redeeming these offers. Okay? So it turns out that the average commuting pattern is a far better predictor of your propensity to respond positively to these mobile ads as opposed to the variance. In other words, the days when you're commuting and doing your standard traveling between work and home, you're far more likely to go for those offers as opposed to when you're deviating. Okay? And we saw something like 1.9x, which is almost now getting into almost 90% increase in the redemption rates for people who are commuting as opposed to who are deviating, right? So some examples stood out which said that, look, you know my home, you know my work, and you're targeting me with a Starbucks coupon. And I have a Starbucks coffee outlet right next to my office. So if you send me a coupon at 8:45 in the morning, I know I'm going to start working at 9. Well, I'm more likely to redeem that offer then. Okay? So if you know my commuting patterns and you are doing a good job targeting me with stores near my home or near my work, and I'm aware of where the stores are and how much I have to walk and all of that, that's really why we were responding more positively to these offers. Okay? Well, following that, then, the next step in the project was, so far everything has been in the digital space, right? Now, a lot of these brands and the marketers came back to us and said, well, this is still 2014. We cannot give up on traditional marketing at all. Is there a way for you to figure out how to combine traditional marketing in the offline world with mobile? Okay. So then we said, okay, yeah, we can do that, right? So think about electronic billboards, right? So if you are in any major city in the downtown or somewhere near downtown, you would see spots with massive electronic billboards. This is where advertisers buy the slots in advance so they can actually show their ads. Now, with the collaboration of the telecom providers, again, we know that Mr. John Doe here is going to be on Saturday at noon. He's going to be at, let's say, imagine this is like Times Square in New York. So I know John Doe is going to be at Times Square in New York at 2 p.m. Well, I also know like which ad is going to show up. So let's say there's a Nike store near Times Square. Nike already has bought an electronic billboard ad to be displayed on Saturday afternoon. Well, if I know that John Doe has, a 75% probability of being there at Times Square on Saturday at 2 p.m., I can combine the offline billboard ad with a targeted mobile offer at that time for him, saying, okay, you are at Times Square and you are like 20 meters away from the Nike store. Today, you get a 25% discount on anything that happens. Okay? And when we did that, when we combined the electronic billboard advertising, okay, with targeted SMS or app-based offers on a smartphone, what we saw that redemption number went up significantly. Now we got 7 times higher. So now we are clearly in the double digits, with respect to these offers. So all of this was, all of this has been, great in the sense that we progressively were able to increase the redemption rates, from the 2%, 3% to high single digits, then low double digits, and finally high double digits. So then, following that study, another, conversation in a bar in Shanghai led to the next project, which was about, consumers behave differently when we are surrounded by completely unknown strangers, right? So in other words, when we are in crowded contexts surrounded by strangers, it can be a very different experience for us as opposed to when we are actually with people we know. Okay? So a typical example is, subway or a train station or an airport or a bus station. For the most part, we are with people that we don't really know, right? So the question really was, well, would our behavior on smartphones and would our behavioral response to advertising or marketing change if we are surrounded by people that we know versus that we don't know? So that led us to the second or the third set of projects in Asia where we looked at, and this was a big project in Shanghai, in China, where we worked with the subway authorities of the city in collaboration with China Mobile. So basically you need a consortium of 2 sets of industry. You need the telecom providers, you of course need the brands, but you also, in this case, we need the public infrastructure transportation providers, in this case the subways. Now if you've been to China, and especially in a city like Shanghai, you know that in the subway system, the Wi-Fi access is pretty awesome, right? I mean, there's almost never a blank spot. Like in New York, you get blank spots all the time. But compared to New York, Shanghai, the infrastructure is very, very advanced. So in this case, what the local authorities in Shanghai had also done was they had installed additional WiMAX boosters in the tunnel so that even if there was a 0.1% probability of the signal dropping, after the installation of these boosters, that number would pretty much go to 0. So what we said is, okay, so the subway trains gives us a very nice context to induce some sort of exogenous variation in traffic. Okay? An example would look, during morning rush hours, you're going to get a lot of crowded traffic in these subways. But for the same route, right, if you were to take the non-rush hours, by definition, then you'll get less crowdedness. So we ran a bunch of field experiments that basically said, to answer the question, like, when should marketers send offers when people are in these contexts, right? So should we be sending offers when they are in crowded contexts versus non-crowded? And turns out that once we did these, when we send the offers across multiple days, across multiple contexts, and what you see on the x-axis is an increase in the number of passengers per square meter, right? So how do we know this? It's because we have data from the telecom providers. Anybody who has a phone that is subscribing to China Mobile, which has about 77% of the market share, would be in the database. So we could track how many people are there in the subway. We also saw a pretty massive variation in the levels of the purchase rates of these mobile offers. So what you see here is that as the level of crowdedness increases, right, there's pretty much a linear and sometimes a non-linear increase in people's propensity to redeem these offers. So following this, then we went back and analyzed like what was going on, right? So we had surveys of these people who had responded and asked them like what was going on. And the story was rather straightforward, saying that, look, when we are surrounded by people that we don't know in context like an airport or a bus station or a train station or a subway station, right, the first thing we do is we take our phone out and we kind of immerse ourselves in our smartphone. You basically have our undivided attention at that point, and if you're able to give us a relevant offer at that time, there's a higher probability that I would actually respond to that offer. Okay? So we then tested that with different products, some belonging to the telecom provider like a missed call alert, some belonging to other brands like a video streaming service, some even completely unrelated to technology electronic products like a coupon for a cosmetics product or a movie theater ticket and so on. And in every case, we consistently kept seeing that relationship, right? And of course, after a certain point, though, when it gets way too crowded, of course, then there's this inverted U-shaped effect. But up to 5 people per square meter, we saw that crowdedness actually increases your propensity to redeem offers. Okay, so the story so far is, what we have done, what I've told you so far is how we captured the value of location, time, weather, crowdedness. But now comes, what I feel is the most fascinating part of mobile, which is, going well beyond the static indicators of information to looking at an actual trajectory, okay, and using that to mine offers, right? So this is a pretty intense set of projects that are being executed even as we speak, and I'll share with you results from 2 particular studies. Where what we are doing is we are saying, look, just because, see, what happens in geo-targeting or in other location-based marketing is I get an offer because I'm in front of Starbucks, or I get an offer from a bank because I'm standing in front of a bank. But I could be standing in front of a store because of other reasons, not because I'm interested in buying that product, right? Now, if you go back to the e-commerce and internet commerce literature in the last 20 years, right? There's a vast stream of literature that people have shown that you can predict our online behavior across different internet websites by tracking which other websites we've been to, right? So, the analogies in this instance are, there are multiple, like Amazon does, people who bought this also bought that, right? Netflix does this. If you watch this movie and you watch the other movie, well, then you're likely to watch that movie, right? So the recommender system algorithm has used this for a number of years now to predict, what kind of book would you buy, what kind of movie would you watch, and the clickstream literature and the practitioners, of course, in the industry have also been doing that for 10 years, saying that, okay, well, if you go to CNN first, then you go to BBC, then you go to ESPN, well, what's the 4th website that you're likely to go to? They can also take it to one level deeper and say, well, within CNN, you should be on the sports page first, and then you go to, the science page and the business page. What's the 4th page within CNN you would go to, right? So this has been around for a while, and what we said is, well, instead of doing this in the virtual world, why don't we take this in the physical world, okay? So if I can observe that you first go to the Revlon store, then you go to Estee Lauder, then from there you go to a 3rd cosmetic brand, then, can I predict what is the 4th store you would like to go to, let's say in a shopping mall context, okay? So that's what we did. So we then started working with various shopping malls in the world, from the US to India to China to South Korea, and we started basically working with, and the shopping malls is basically a consortium of, multiple stores, right? So this is an example of a mall. And the question is that if I know that John Doe walks in and then he first goes to, this is a jewelry store, then he takes the escalator, he goes to the luggage store, then he goes back to buy a Starbucks coffee from here, then he goes to the 7th floor and, goes to some other brand. Well, that information, that trajectory is very informative because it is going to give me additional information beyond my predictors like location, weather, time, and crowdedness, right? And I'm basically interested in building a recommender system that would take John Doe's trajectory in the physical world and predict what are the next set of stores he's likely to go to. So that's what we sort of did. I'll show you one case study. This is the largest shopping mall in Asia. It's based out of Beijing. It has about 1.3 million square feet. It gets about 100,000 people per day on the weekdays and about twice that number on the weekends. And it has about 300 stores, of which about 250 participated with us, right? So the way this is done, the way the trajectory data is accumulated is through the Wi-Fi system, right? So as soon as people sign on to the Wi-Fi in a mall, basically the Wi-Fi is able to track, not only just where they're going, but far more granular data. And all of these malls, at least the ones we worked with, the way this was done is, obviously very transparent. In other words, every user who gets access to the Wi-Fi is given a flyer saying that conditional on you, signing up to the Wi-Fi, we will be using, or the mall would be using your data in real time to send you offers in real time. Okay? So we were anticipating, opt-in rates of, 5-10%. We got opt-in rates of close to 70%, 70. In other words, 70,000 people on a given day would say, yes, I want to sign into the Wi-Fi, take my data, but can give me a relevant offer. Okay? And a similar pattern we are now seeing in other countries too. So that's where, like I was saying, consumer behavior fundamentally is very similar across the world, where more and more people realize that there's a give and take relationship between companies and them. So in other words, the more information you share, the more relevant offer you can get. Okay, now back to the problem. I basically, if you play ice hockey, this is a quote from an ice hockey player in Canada, where it says that I skate to where the puck is going to be, not where it was. In other words, I want to predict where the consumer is going to be, as opposed to try to analyze like what happened in the past. Okay? Now, how do I build the recommender system? What we need is basically, we first need to identify a community of people who are very similar. Okay? So I could have data on, so let's say Wolf has been in my customer database for a while. So I could have a lot of data on Wolf, right? I know a lot about his preferences. Okay? But let's say Wei is a new customer. I don't know a whole lot about Wei. I know a lot about Wolf, right? So what I'm going to try and do is figure out a similarity in preferences between Wolf and Wei, and then give Wei offers based on how similar, how dissimilar he is to Wolf. Okay? The question then becomes, and this involves massive mining of machine learning. So if you've used like dense subgraph detection, we had to use that as well using Markov clustering. But the question then really is, what are the dimensions of similarity, right? I'm not so much interested in demographics because, demographic has been like, been there, done that. You've done this for a number of years, and it's great. But I want to get to the level of granularity with the trajectory that I mentioned. Okay? All right, so what are the dimensions? I know, for example, I know the temporal patterns. If I have two consumers, I know when they started the shopping session and when they ended, okay, based on when they're logging onto the Wi-Fi. The second thing I know is their actual semantic patterns, which is, okay, this person goes from the basement to the first floor, then the 7th floor, then the 5th floor, right? So I basically can figure out their entire vertical and horizontal trajectories. The third thing I know, and this is the most critical dimension, is the semantic dimension, which is, what is the visit probability of going from the Nike store to the Estee Lauder store to the Starbucks to the Gucci to the Armani, right? Not only do I know which stores they're going to, but also how much time are they spending in the store. Okay? And that time in each store is a very strong indicator of, are they likely to buy or not. And then finally, the velocity. So some people are very efficient shoppers. They know what they want. They just go and get their things done. Some people take their time. So based on these 4 dimensions, then we build a recommender system and, using the weights from these 4 dimensions to figure out how similar is my new customer Wei to my existing customer Wolf, and then send them offers accordingly. Right, so this was, like I said, I'll just to give you a insight into the field experiment. You need to have, obviously, a very carefully designed control group, but also multiple treatment groups. Because, the whole premise of mobile advertising is, how do I know that, Wei would not have bought that product anyway? What if I had not sent him an offer? He may still have bought the product, right? Well, then my entire advertising is really not that useful. I want to measure the incremental effect of sending an ad to a new customer, okay, after systematically controlled for the probability that he or she would not have bought that product. So in the first set of studies, we got about 83,000 folks who were part of our projects. And like I said, of the 300 stores, about 252 of them actually signed up. It took a long time to sign up the first store, but once the first store's results were published, there was a domino effect. Every other store in the mall wanted to say, yeah, please sign us up too. Okay? And it turns out that, and this completely blew us away in terms of the magnitude, right? So when you incorporate the trajectory of these people and then design offers, there is a gigantic improvement in the redemption rate. So remember I told you about 2% and 3%, then we went to 7 and 8 and 10. Well, now we were seeing 31% redemption rates. That's basically saying 1 in every 3 people who got an offer were redeeming these coupons. And not only were they redeeming it, they were also spending more money in the focal store, plus they were spending more money in the mall. But that wasn't the end of it. They were actually spending less time as well, right? So this is useful for 2 reasons. Obviously, every store wants people to buy more products, right? So they're selling. But they also don't want a lot of people assembling in their store at the same time. So they don't want crowdedness, right? So they want efficiency as well in some cases. So what we saw was using that very rich granular data, right, with the finely targeted trajectory advertising, we could not only increase revenue, but also increase efficiency. In other words, give people what they really want, and you're going to get this in and out behavior. Okay? Get them in, get them out. Other things, one thing that stood out was that trajectory-based advertising was fantastic on weekdays, okay? But on weekends, it turns out that there were other kinds of mobile advertising that were more effective, right? So one thing that we saw was that on the weekend, the trajectory was actually, our new recommender system was not working as well as some of our previous systems, such as when we did random advertising or location-based advertising. And then when we analyzed the data and again went back and looked at consumer behavior, what it turns out was on weekends, right, the trip to a shopping mall for many people is a social trip. Like, you go with your family, you go with your friends, you don't want efficiency. So a lot of people actually prefer to explore things, they seek variety. They're not looking to be like in and out. So on the weekends, it turns out that trajectory wasn't doing as well as random. So that was an important distinction as well. But what that made is that made us realize that, look, and in hindsight, everything is 20/20. But what it made us realize is the propensity of people to respond to these mobile offers is also influenced by whether you're shopping alone or if you're shopping with family and friends. Okay. And then that's something that we had not considered in the first set of studies in the Far East, but then we realized, well, we should. So the next set of studies actually incorporates information on, whether people are shopping alone or they are shopping with family or friends, okay, and uses that then to customize these offers, right? So again, to figure this out based on trajectory, we have to use these dense subgraph detection techniques. But now the problem is a little more complex because I'm not just tracking one person. I'm also trying to see if these people are part of a dyad. Are they together? Are they part of a triad? And so on. So beyond 3, it becomes much more difficult. So like from 4 onwards, like detecting whether 4 people are always together because they are part of a family or friends, that becomes harder. So at 3 to 4 is when you're able to see the maximum level of effectiveness. So here, again, we ran a bunch of field experiments over 3 weeks. So we got about 52,000 responses from those stores. And we have used Bayesian models because, as opposed to the first study when we are targeting individuals, there's a lot of unobserved, diversity and heterogeneity amongst individuals. So you want to control for that sort of unobserved heterogeneity. So we used some Bayesian models to figure this out. And that was interesting because it gave us some, additional insights into consumer behavior as well, which is, the same offer for the same product for the same brand at the same time, the propensity will differ based on, your gender, your age, are you with other people, and so on and so forth. Okay? So here's some, high-level insights. For example, one of the things that income, for example, is a very big predictor. But we did not find, typically the high-income people were actually not shopping in large groups. So typically we would find that high-income people are individual shoppers or at best in dyads, not so much in triads or quads. The other thing was, mobile advertising, before some of our studies, there was also a fair bit of misconception that the high-income people do not respond to mobile marketing. Okay? And actually, consistently from Germany to South Korea to the US to China to India, we saw the exact opposite. It's the highest income bracket, right, based on any sample, that is far more responsive to mobile marketing than anything else. And why this is useful to know is there's been a lot of debate about customer lifetime value using these smartphones and so on. And so, who are these people? Are we attracting the stragglers, the highly price-sensitive people? Or can we also attract the people that marketers really are trying to target, like these high customer lifetime value people? Well, it turns out that income has a very strong positive association with these offers. Okay? Then we saw some pretty strong gender effects, how men and women shop. We also saw that in general, the larger groups were more responsive to these offers. So the triads were actually more responsive than the dyads, who were more responsive than individuals. Couples were the least responsive. Okay, so we call this the attention deficit order. However, between the couples, older couples were more responsive than younger couples. Okay? We saw more women who were more likely to shop with friends and family as opposed to men. And finally, the last thing is, aside from the income effect, is, we started looking at the social coupon effect, which is, look, a brand, suppose you're trying to look at a 50% discount. You can do one of two things. You can say, well, buy one and get one free, or you can say take 50% off, right? So conceptually, in terms of, the actual price discount, they're about the same. But they do, in fact, elicit a very different behavior from people. So couples, for example, you'd see are far more likely to redeem those social discount coupons, buy one, get one free. So if I am trying to target, a diet, right, I'm better off sending them a buy one, get one free as opposed to sending, one of them just a coupon for 50% off. And we, of course, experimented with different levels, but we kept seeing this over and over again. So to wrap this up, sort of the key takeaways, or at least the future that I think is, so, many retailers and many companies have seen a fair bit of success with, mobile marketing, and whether it's using location or time or weather or crowdedness. And now what we are doing now is we are trying to basically mine the behavioral data of people in real time to see if we can make these things better. And the good news is that based on about 4 or 5 different case studies in different countries, what we are seeing is, yes, you can actually make things better. And you can take the responsiveness from the single digits to as high as 31%. Now, obviously, the use of this data can be multifold. And in these studies, we have been using a wide variety of data science techniques, machine learning, field experiments, statistical modeling, surveys, and so on. And seeing that, these real-time social effects do matter, whether you're shopping alone or with friends or family, or whether, you went to three consecutive stores in the same category versus whether you're going to an eclectic set of stores. These things are very highly predictive of what your future shopping pattern would be within the same track. Okay? So what's the what I've learned in the last 10 years looking at this in different parts of the world is, what I learned is that basically consumers are more and more demanding. So and it's not just about millennials. So I often get this question that, are you only talking about millennials? And it's not. We have seen the data being more or less consistent from millennials to Gen Z to Gen Y, sometimes even Gen X. Okay? Obviously, the proportion of adoption is different, but the patterns are actually upward sloping. In other words, even with Gen X and Gen Y and Gen Z, over the years, more and more people are saying, here's what we want. We want brands and retailers to know who I am, where I am, what's nearby, what I'm interested in, what I should respond to, where I have been, what I need, and so on and so forth. Okay? So, and this, over the years, it's obviously been a great learning for me and my colleagues that just because I think in a certain way doesn't mean that the world out there will think the way I think. Okay? The world out there, in our data and in our opinion, is a vastly different and fast-growing world than at least what I personally may have, conceived it to be. And when we started this, 10 years back, right? Clearly, the slide scale between data privacy and value would have looked something like this. I can guarantee you this, and you can, believe me or not, but I can guarantee you that that slide is now the other way around. In the vast majority of cases, right, in the world of mobile marketing or advertising, or across retail, telecom, banking, fast food, apparel, whatever it is, we looked at a total of about 15 different industries in the last 10 years. That slide is gradually shifting, and it's the other way around. In other words, consumers are saying, look, we understand this economics, right? What we don't want is don't overwhelm us with offers, right? If you're giving us offers, make sure it's relevant, and then, have some sort of limits on the number of, ads or offers or notifications you send to me, okay? Which is different from 10 years back when people would say, no, I don't want anything to do with you guys. I'm not going to give you anything about my data, and so on. So that conversation has shifted quite dramatically. So I'm actually just, to wrap it up, writing all of this. I have a book that's coming out in the fall. It's called Tapping the Crystal Screen. Basically, I'm saying that when you tap the mobile phone from a consumer perspective, we get a lot of data. Right, but the reason it's called the crystal screen is not just because the screen is crystal, because your smartphone is very predictive of what you're likely to do. Okay? So, and this discussion would be a big part of that book. So I think I'm out of time, and I know I'm standing between you and lunch. So I'm happy to take questions now or over lunch.
Do the question now, but first thank the speaker.
Yeah.